Hey guys, welcome back. In the last two videos, I showed you how to use the definition of a derivative to find the derivative for a polynomial, which was, I believe, x squared plus 2x, and then the other one was with a radical, which is the square root of x. In this video, I'm going to show you how to find the derivative of a function that's rational. So first, let me remind you guys, the definition of a derivative is the limit as h approaches 0 of f of x plus h minus f of x over h. This will help us find the slope of the tangent line, okay? And this here is basically a notation looking like this, f prime of x. Now, I drew the function that I'm going to find the derivative of, which is 1 over x. Now remember, we're going to be looking at the slope of a tangent line. I want you guys, before you do anything, take a look at this, the slope. Isn't the slope just about negative everywhere? All these slopes are negative. So when I take the derivative, or when I find the derivative of 1 over x, I better hope that all the slopes are negative, okay? So let's take a look at it. Find the slope of the tangent line for the function 1 over x. Well, every time you see an x, you have to plug in x plus h. So that's this guy right here. Now I'm just going to use that definition from the beginning of the video, which is f of x plus h, which is this guy here, minus f of x all over h. You have to find the common denominator. Now, if you guys are keeping track with all my videos, I do something called crisscross tomato sauce. It's a very fast and easy way to add fractions. I go like this. There's criss, so that's 1 times x. Cross, I'm going to do the other one. You have to make sure you take the sign with it. Cross, so negative 1 times x plus h. Okay, negative x, negative h. Tomato sauce. All right, so tomato sauce is going to be this guy here, x times x plus h. We're not going to multiply that in though. So if you can also just find a common denominator the way that your teacher taught you. I just like crisscross tomato sauce. Okay, and then that's all divided by this guy here. So I combine the fractions. I go x minus x is 0, right? And I have a negative h over x times x plus h. Now, if I divide that by h, which is h over 1, I can keep change flip, and I get 1 over h. Or you could just put this right here next to them. This crosses out with this. You're left with a negative 1 on top over x times x plus h. Now, remember, we have to apply this limit as h approaches 0. So, when we say the limit as h approaches 0 of this guy here, that's going to give you negative 1 over x squared. Okay? So now, what we just did was we said if f of x equals 1 over x, then the derivative is going to be negative 1 over x squared. And we showed that by using the definition of a derivative. Okay? So, what is the slope of the tangent line of the function at the x values below? Well, once again, since I know f of x is 1 over x, I just found out that f prime, which is the derivative, f prime is negative 1 over x squared. And I want it at the x values below, 1 and 5. So all I got to do is plug in the 1 into the x, the 5 into the x. Notice, guys, that anything squared is always positive, and the negative in the numerator is going to make this expression always negative, which will show what I was showing you earlier with the graph here, all these negative slopes. Okay, so I hope that makes sense. Now, at negative 1, it's just, at positive 1, the slope is negative 1. When you get down to somewhere like, let's say, 5, you get negative 1 over 25, right? So that means 1 up 25 over. So it looks like this, but obviously it's in the other direction since it's negative, and that's that slant there. So I hope this made sense. For a fraction, when you're using the definition of a derivative, you're going to have to combine and make it into a single term and cross off terms that match and reduce it, apply the h approaches 0, and then that's how you would get the derivative for that kind. And those are all three types of derivatives that we like to use the definition of a derivative for. So I encourage you to slow down the video, try some problems. In my next video, I'm going to do the 3 types all in one video. So I hope you come back and watch it.